Welcome back to ECE 320A. We're working through some review problems for exam number 4, and this is actually problem number 5 from the fall of 2015 exam, which is asking us to find a transfer function between this input signal, which is actually a current source, and the output, which has been labeled as the voltage drop from top to bottom across that resistor R sub 2. We want to now find that transfer function, and there's many different ways. As if you have looked at the solutions, you can work this many different ways. A lot of times students like to work problems using mesh analysis. That's fine, but you're probably going to want to immediately be thinking in the S domain. Now you could draw these two currents and note that I sub 1 is actually equal to I sub I, the input current, and you really don't have to worry about KVL in that mesh. And then your output would simply be V sub R2 is equal to R sub 2 I sub 2 of S. You would then need to find I sub 2 of S in that two-mesh formulation doing the mesh analysis. Plug in the I sub 2 that you just found into this expression, or scale I sub 2 by R sub 2, and I sub 2 will be a function of capital I sub I, and you'll then have your transfer function. What if we went ahead and did this a different way? Suppose we did nodal analysis, and now we might say, oh, we have this one node, and that's V sub 1. If we collect that impedance, this is now 1 over SC, and this is simply R sub 2. And we have this impedance, which here is SL, and here is R sub 1. So if we write a KCL equation in terms of V sub 1, then we have I sub I coming in to node V sub 1 from the left horizontally. This is coming in there, and I'm doing the Laplace transform sort of in my head of all of these quantities. That's now equal to the two currents flowing out of that node, which we have V sub 1 over R1 plus SL. That's the current going vertically down the first or the middle branch, plus V sub 1 over the impedance in the rightmost branch, which is 1 over SC plus R sub 2. That's now what we need. We now have 1 over SL plus R sub 1 plus, if I wanted to, I could obtain a denominator in the denominator and put that upstairs. So I now have SC over SR sub 2C plus 1. Hopefully I'm doing the math right, factoring out the V sub 1 of S, and that's now I sub I of S. But we didn't need, that would now give us this transfer function V sub 1 of S over I sub I of S is now 1 over this ugly mess, 1 over SL plus R1 plus SC over SR sub 2C plus 1. That's my transfer function between the current source I sub I and this node in my circuit V sub 1, but that's not the output that I need. I actually need V sub R sub 2. And V sub R sub 2, I hope you can see, is actually just a current divider away from V sub 1. V sub R sub 2 is now R sub 2 over the sum of the impedances in that branch, which is R sub 2 plus 1 over SC, and that's now V sub 1 of S. Or this is now S R sub 2C over S R sub 2C plus 1 V sub 1 of S. So if we wanted V sub R sub 2, which we do, that's our output, v sub r sub 2 of s is now going to be this s r sub 2c over s r sub 2c plus 1, scaling this transfer function for v sub 1 of s. So this is now 1 over s L plus R1 plus SC over S R sub 2C plus 1, and that's going to be I sub I of S. And this, if you clean it up a little bit, that's now your transfer function, and you would probably want to write this in terms of just a numerator polynomial over a denominator polynomial. But this particular factor will actually cancel that term, and we'll have this particular piece going upstairs eventually, but everything will start to clean itself up, hopefully, and you'll see, well, if we just do that, let me try to do that. Here's S R sub 2C. Then I'm distributing that S R sub 2C plus 1 in through the two terms, and I now have S R sub 2C plus 1 over SL plus R sub 1 plus SC. That's now my H of S. But if I put that all now over this and multiply by 1, which is SL plus R sub 1, then I actually have what I need. I have S R sub 2C times SL plus R sub 1 all over S R sub 2C plus 1 plus SC times SL plus R sub 1. And that should be my transfer function if you were to multiply things out a little bit more or not, but that should give you the transfer function that is H of S equaling V sub R sub 2 of S over I sub I of S.